Welcome to this e-learning series on HANA Basics for Developers. This is the introductory video in the series, and really a little bit of background as to why I decided to create this series. I heard from a lot of developers that they wanted to begin working in the HANA world, and the problem was that there wasn't enough information. It was almost as though there's too much out there. There's lots of blogs and e-learning videos and open SAP courses, and they cover the basics as well as intermediary topics and new Delta information. But part of the problem is if you go back to the oldest materials, they'll explain the basics pretty well, but they do it in the context of HANA 1.0, and they often use outdated development techniques and development tools. And the challenge for people when they're trying to learn something new, something as big as HANA, is you start seeing things and you're not sure which parts are older and which parts are still valid in the current world of HANA 2.0. So what I wanted to do is go back and actually looked up a lot of the older materials that we had and just updated them so that all the demos and all the context that I'll be talking to you about in the series will be HANA 2.0, SPS 3, the latest available version of HANA. And as far as developers are concerned, all the development tooling and techniques that we'll use all the latest concepts, XS Advance, and the HANA Cockpit, and the SAP Web IDE for SAP HANA. So no outdated approaches, no outdated development tools, but yet we'll start with the assumption that you really don't know hardly anything about HANA and go through the basics. The other thing that we'll do is, because many of you maybe worked in HANA in the past, and maybe you've done a little bit of development, maybe you've used the HANA Studio for administration and development. We'll also do some a little bit of basic Delta to help you get your skill sets, your basic skill sets up to date. Now, I'm producing this video here in January 2019, and it's just a few weeks before a new Open SAP course comes out. And I thought this was a perfect time to go over some of the basics. Many people would be taking the new course that will explain all the great new things in HANA 2.0 SPS 3 and go deep into many subjects. That's not what we're going to do in this series. We're not going to go super deep, but we're going to help you get back up to speed on the basics, or maybe it's your first time looking at the basics, but do it in this more modern context. So it's a great little catch me up. If you haven't taken one of the latest Open SAP courses, this will help you get back up to speed so that you can dive right into the Delta materials that are presented in so many of the Open SAP courses. So let's go ahead and jump in here. So first of all, let's go way back. Let's assume you don't know anything about HANA. Let's talk about the original value proposition of HANA. And to do that, we have to look at how traditional databases worked in the past. So what we saw there is that you have all your data and it resides on disk, generally hard disk, spinning platters, magnetic media, maybe solid state, SSD was a little bit faster, but for the most part, in order to process any data inside of a database, the data had to be copied first into memory, and then the CPU could access it from memory, and you're almost totally I/O constrained, the input-output to and from the disk. And in this case, what you had is you had databases that were designed for many different hardware platforms, many different configurations, but it wasn't really optimized for any one of those. And we look at what is the big difference here with HANA. And of course, everybody immediately latches on to the fact that it is in memory. We'll talk more about, what exactly does that mean. But basically, because of advances in computing hardware, we see with 64-bit computing, we can address much larger pools of memory, We see HANA systems supporting up to 20 terabytes or more of memory in a single node, a single piece of hardware. So now all of a sudden it's possible to take all of your data that's in your database and store it in main memory. And of course that gives us immediate performance boost. You know, we're talking about putting data in main memory. We're getting 100 gigabytes per second or more throughput on that. But it also pairs really well with the modern CPU architecture, where instead of a single CPU that just gets faster and faster each year, what we see is we're adding more and more cores to the CPU. And it brings in the concept of having to process data in a massively parallel kind of arrangement. And there we see, by having the data in memory, different areas or different cores in the CPU can be assigned to different areas of memory and still have a dedicated channel to read and write from that area of memory. So we remove the bottleneck of the disk by first of all putting all the data in memory to begin with, and then accessing data from memory isn't just faster, it's more efficient. There's more channels, there's more communication paths to talk to the memory per CPU and per core than what we would have with disk, where you'd have a single bottleneck of the I/O to the disk. We also see with HANA, you know, memory and massively parallelization isn't the only major change. We see that HANA is also stores data in columnar format as well as row format. I'll show you visually in another slide what that means. We can take advantage of huge amounts of compression. The compression is more efficient because of the way we store data in columns. We'll see that in a minute, but also because it's in memory and massively parallel. Once again, we can compress it more than what it would be on disk at a lower or the same cost of processing speed. We can partition the data and store it even in separate physical servers. That allows us to grow beyond even the physical limitations of how much memory. I mean, 20 terabytes is a huge amount, but you can go even larger than that by having multi-node HANA systems and spread the data out across multiple physical machines. We also do a delta mechanism where we're only insert data on a delta, on a change, and we have a whole change mechanism. But with all this and the fact that, you know, we're taking advantage of the latest hardware capabilities, we've really minimized input-output bottlenecks. We're highly optimized for the x86 and the Power platforms. HANA is still very much like a traditional database. The way that you program for it, we use standard SQL. You're not having to learn some crazy new language or variant of SQL in order to interact with HANA. It's very compatible with other databases. You can lift and shift existing SQL code with minimal changes and bring it into the HANA environment. So the things that you know about databases today still hold true in HANA. All these advancements about putting the data in memory, about using the column store and partitioning. We've done all the work behind the scenes to make sure that is transparent, that it just works, and that we can still use a common SQL interface in order to interact with HANA. And the final point, sometimes there's some misconceptions about what in-memory means. Yes, all the data is stored in memory. Yes, it's processed primarily in memory. But I remember in the early days, people would ask, well, what happens if the power goes out? Of course, we persist the data on disk as well. We use normal database mechanisms of logging, have a redo log, and that redo log is written to the disk. Now that disk in these days might not be hard disk drives, spinning platters, probably SSD, solid state, or even NVMe now. Gives us even improved performance for the logging and backup and system startup. But of course, if you pull the power, if the system crashes, it will start back up from disk. The data is persisted beyond just memory. But we have the speed of the processing of knowing that it's always going to be processed in memory. Okay, so some of these hardware and software innovations that have made HANA possible. Today we see servers with many multiple cores. 20 CPUs, 24 cores per CPU. That's not an inconceivable hardware. I actually went out to look at what the certified hardware for HANA is, and that was one of the upper end kind of systems. But that's a single server with 20 by 24 cores. That's an incredible amount of parallel processing that's possible. And of course, we can have multiple blades or multiple servers or multiple nodes, and it's all kind of the same terminology for this idea of just having separate physical systems. And even the data in a single table can be spread out across multiple systems. And today we see, these enterprise class servers. They're less than $50,000 a server. So the price has also come down for how much power that you're getting, how much memory, how many CPU cores. It's just amazing how the prices come down and made this accessible. The 64-bit address space, 20 terabytes or more of memory in a single server, and the ability to have multiple servers in a single HANA instance. 100 gigabytes per second throughput on data parallelization, and that's a conservative number. There are higher throughputs that are available as well. So basically, a dramatic decline in the price per performance ratio has made it completely feasible to store all your data in memory, and then to be able to innovate on the software side, to be able to introduce the idea of not having to physically aggregate and store those aggregations, to be able to do all your aggregations on the fly, to do ad hoc processing, to combine your OLTP, your transactional processing, with your OLAP, your analytic processing, on a single copy of the data. That's also another amazing innovation that HANA brings to the database world. And we see the ability to combine structured and unstructured data. So text analytics and geospatial, and all these innovative things that we've been able to bring into HANA, and not by tacking on another server into the environment and making a copy of the data and processing on that copy, but a single copy of the data that we can do all these things to in real time. And that's where we get the true innovation with HANA. Now, we talked for a moment earlier about column store. And this is a major difference with HANA. Almost all the data in a HANA system is stored columnar. Now, you first have to understand traditional databases store data in a row store. And that means that in a table you might have multiple columns. Like here we have document number, document date, sold to, value, status, and sales org. In a row store, all the data for a row is stored contiguously on disk or in memory. So you'd have the little fragment of data for the document number and the fragment for document date and sold to, value. That's what's stored here contiguously in memory, as we see in row 3 of the row store. And that's pretty efficient if what you're doing is reading a single row of data. If you have the key and you go access it and you want the entire row, that works pretty good. But that isn't what we're doing most of the time. Generally what we want to do is we want to scan through all the rows, and we want to, for instance, find all the sales orders for a particular sold to, or all the records that were sold had a certain document date on them, or where the value is greater than a certain amount. And what that causes us to have to do in a row store is to skip all around and read data from this chunk, then this chunk, and that's what you see in this bottom diagram in the row store. We're having to jump all around and scan across a column, but that causes us to move all over disk, or even when this data is stored in memory, have to hop all around memory. This also means that common data types are not necessarily stored next to each other. So in this case, we might have a document number and the document date and a sold to stored contiguously on disk or in memory. And they might be different data types. Maybe one's numeric and one's a date column, and maybe one's a character column. And that begins to impact our compression, because compression works best when you have similar data and similar data types stored near each other. And if we're constantly changing the data type, then we're not going to get as good a compression. If we look at it over here, and this is how HANA mostly stores data, is in a column store. And what we do is we take and we say, oh, we got a document number column. We're going to store all the data for all the document numbers contiguously in memory. We got document date, sold to, they're all stored in chunks of that particular column. And right away you see, one, this is more efficient storage, because if, for instance, we don't have a document date in all the columns, we don't have to leave blanks. In a row, if I don't have a value, I still have to store a null there, and I still have to take up the space that would be allocated to that column to keep the rows contiguous and to keep them the same size. I've got to store that. But if I'm storing by a column, I can leave those out. And the other thing is here, now all my same data types are stored together. So all the document dates are stored together, all the document numbers. So they're of course going to have the same data type, and we're going to get lots of repeating values, lots of similar values. So you're going to get much better compression. So you see the document number here, well, that's probably a unique value. Every record has a unique value. You don't get great compression there, but document numbers and sold tos and fixed values like sales org and status, they get excellent compression. So we're getting much more efficient storage of the data. Now, this does mean that when I do want a single row, say I do select single star for row 3, I have to build a virtual row. So this is where the in-memory part makes columnar storage possible. I mean, it was possible in the past, even on disk store, but it wasn't terribly feasible because of this problem, having to create virtual rows. But because the data is in memory, what we can do is we can store a row hash, if you will, that tells us the memory addresses of all the different parts and pieces that make up a row. And therefore we can reassemble this row very quickly on the fly when we need to, when we need a single row, because we have all these memory addresses. And because it's not as costly to skip around when we're dealing with memory. We're not having to wait for the spinning platter to come back around or something like that to read the values. So being contiguous isn't necessarily as much as a necessity as it is when we're dealing with disk, physical disk. Now, on the other hand, when we do want to do those scans, say, well, give me all the records where document date equals today, it's much more efficient because now we can scan the data as it is stored together in memory. And we can do processing over the compressed data without having to decompress it, because the compression algorithms are built into the scanning algorithms inside of HANA. So we get very efficient real-time access to the data. And this has a pretty big impact for developers, because this is going to change completely our programming model. Our traditional programming model, which if you come from the ABAP world, you're probably very familiar with this. We did very little inside the database. Instead, we would move large amounts of data to the application server, and that's where our business logic was. So we did a lot of our aggregation and sorting and just generally our processing at this application server layer. And this created a huge bottleneck because we were having to constantly make massive copies of the data between the database layer and the application server layer. In this new model, in the HANA world, because we can do all that processing inside the database in real time, all our aggregation, our summation, our sorting, our filtering, it should all be done in the database layer and not at the application server layer. And that only the final filtered results really need to come back to the application layer. And the application layer takes on a different responsibility of primarily being used to present the data, to format it just for the output, to service enable it. And the database continues to do all the heavy processing. This also means that our code, our logic, it moves into the database as well. So it means learning some different techniques, learning to create logic blocks inside the database, stored procedures, usage of views, more powerful SQL concepts than what we're used to. So we'll take some time in later exercises to talk about this change to the database development and how much more that we'll do inside the database itself. And if we see the impact that this has on the shifting of responsibilities within the traditional application server stack, going back once again to those of you, many of you are probably ABAP developers viewing this video. That's my experience out there talking in the SAP world. You know, the traditional ABAP world, you had your SAP GUI, and it talked to the ABAP application server, and the ABAP application server was really the center of the universe. It's where we did our user interface rendering, our application logic, really a lot of database processing. And we treated the database itself as just a dumb data storage bit bucket where we read massive amount of data up out of and do almost all of our processing at the application server layer. In the HANA world with HANA native applications, we rely on the database to do almost all of the processing. If I could have created the boxes to scale of how much processing, this index server process inside of HANA would be huge. It would take up the entire slide. These would be tiny little slivers. We do have an application server similar to the way that in the ABAP world we have the ABAP application server. Here we have something called XS Advanced, Extended Application Server Advanced Model is its full name, and it's lightweight application server based upon Cloud Foundry. So we have the same application server architecture in the on-premise HANA world as what we do if you do your development in the SAP Cloud Platform. And here we have multiple runtimes. We can do JavaScript development using Node.js. We can do Java development using Apache Tomcat or TomEE. And we can do Python development. And this is where you do your procedural logic. That means processing one record at a time, maybe doing input validations, doing output formatting, creating services. But the point here is that all of your data intensive logic, even your application logic that's data intensive, happens down inside the database using SQL and our stored procedure language, which is named SQL script. We only return the data to the application server that we actually want to present to the user on the client side, so an already filtered, paginated set of data. The application server is, as I said, responsible for taking input parameters, validating them, taking the output, presenting it in a way that the client can consume it. You see the other shift here. We go all browser-based, SAP UI5, HTML5 based rendering, JavaScript on the client side. We'll talk more about how these different layers work in the future, but it's helpful to have a general understanding here of the change, the massive change in the paradigm of how we develop in this environment. Okay? And of course the topic of the day is speed. We talked earlier about how the bottleneck in the past has been disk, hard disk. If we look at some of these numbers here, and I want to stress, I updated some of these numbers. I took an older slide, and of course technology has improved. CPUs are faster, memory is faster, disk is faster. We see with advent of NVMe disk storage, 2,000 nanoseconds as opposed to SSD 200,000 nanoseconds access time, as opposed to spinning old style magnetic disk hard drives 5 million nanoseconds. These numbers are appropriate in scale. I want you to take that away here, and of course I'm sure somebody can find examples of, there's an SSD that's this fast or that fast, but the scale is what's important here. Traditional disk, even if you have the fastest disk, NVMe, is still a magnitude slower than memory access. And then HANA is also, we talk about memory, and of course maybe we kind of lump that into one thing and we just call it memory. But there's actually different layers here. Of course we have main memory, but HANA is also designed to take high advantage of the different levels of caching, of the L1 cache, the L2 cache, and the L3 cache within the CPUs and the cores themselves, and do a lot of high efficient processing at that level. And we see the more data that can be processed in the L2 or the L1 cache, the faster that we can get it. Main memory is 20 nanoseconds, and L3 cache is 15 nanoseconds, L2 cache is 4 nanoseconds, L1 cache is 1.5 nanoseconds, and we have worked with our hardware partners, with Intel and IBM, to really take these compression algorithms and aggregation algorithms and the other kinds of unique HANA processing, and optimize it to take full advantage of the different levels of cache in the CPU as well. So it's not just about main memory. And all of this, of course, gives us incredible speed, but it's that speed, not just for the sake of speed, not just so your report runs in 1 second as opposed to 4 seconds, but it opens up a world of possibilities to work on data in real time without aggregation, to be able to combine processing, analytic processing, and transactional processing on one copy of the data, to be able to bring in geospatial processing, text processing, graph processing, JSON processing, all these things on one copy of the data. It's speed to an end, and that end is better business applications, more innovative applications. So we see this, this is one example where we can take the speed and we can put it to good use. In the old world, we would have our transactional processing system, our ERP system, our CRM system. That's where the individual transactions are coming in. And then we would have a completely separate OLAP, or analytic processing system, like a BW or something like that. And what we would have to do is, probably at night, we'd run some jobs that would extract the data out, ETL jobs, transformation jobs. They would aggregate the data and store the aggregations and different copies of the aggregation, so that we could run reports in real time. In real time meaning the report executed in a few seconds, but it wasn't real time because the data was already old. It was stale. It could have changed from the time that it was extracted and transformed. And this also adds cost, because now we have to have the processing to do this transformation. We have to store these aggregates. We have to have a separate system to do it. In the HANA world, we can do that kind of aggregation on the fly without making a copy of the data. So your ERP system, that is your transactional system, you can do your analytic processing directly on top of it as well. And you get real-time look at the data. We're not having to transform it and store that transformation. We're not having to wait for those jobs to run at night. We're seeing the real data as it's changing. All right. Now, I've told you a lot about the various innovative things that are part of HANA, and I hope you walk away with a good understanding of some of the background of why we created HANA and what makes it unique. But sometimes this scares people a little. They think, you're talking about in memory and Columnar. This must be very weird to program, and it must be, have to use only SAP proprietary tools to access it and things like that. But that's all myths and incorrect information. So I want to close out this first topic here by showing you just how easy it is to access HANA and just how standard it is for developers. So what I've taken is I've downloaded this tool called Squirrel SQL Client. This is just a very standard open source little tool that is designed to interact with databases. Not created by SAP. There's actually nothing in here that knows anything about HANA. It's just an off-the-shelf tool, and I use this on purpose to show you just how open HANA is. And what I have here is I'm going to connect to my HANA database. I'm going to use JDBC, Java Database Connectivity. HANA has drivers for JDBC, ODBC, .NET Provider. We have Node.js drivers, Python drivers, Ruby. We have a whole slew of drivers for different environments. That's just how open HANA is. And I'm going to use that to connect to the system, username and password. I just give it the URL of my system, and I can go ahead and connect. And give it a second here to pull back my information. And what you see here on the left-hand side, these are all the schemas that are in my system. And you might recognize some of these. Here's S-Flight. Open my tables. Oh, here's the S-Book. Shows me my columns that are in my table. What are the primary keys? Here we are. What columns are available? What are their data types? Decimal, n varchar. Is it nullable? I can read the content. Oh, that example. I picked a user that doesn't have access to that table. We'll come back. Let me come here to another schema where I have access to tables. Let's come here. Let's look at this one. Here I can view the data that's available inside my table. I can even come here. Maybe you've heard of calculation views. That's a special type of view inside of HANA that allows us to access that analytic engine and do some of that OLAP processing that we talked about. I can come here and I can run these calculation views. Here is the select against a particular calculation view that's bringing back some buyer information. And as I said, this is a tool not designed for HANA, doesn't know anything about HANA. It's just using standard JDBC and sending standard SQL queries into the database. It works. It works with HANA out of the box. I can come here to the SQL console. This is something that maybe you're used to, writing your own SQL queries in whatever language you're familiar with. Maybe you're used to doing ABAP and just writing OpenSQL inside your ABAP programs. I'm just going to come here and I'm going to say select star from users. I'm going to execute that, and there, I see the data come back. So not some weird proprietary language that we use, not some strange variant of SQL. Very standard ANSI SQL that even a third-party tool that knows nothing about HANA can utilize and interact with. So on one hand, I hope you walk away from this first lesson having a better understanding of the unique power and architecture and capabilities of HANA, but at the same time an appreciation for the fact that even with all those unique capabilities, it's also extremely standard in the way that it can be used, the way that it can be accessed, and the way that you can do development.